Welcome to the series, The Evolution of Everything. Phase 1, The Accidental Breakthroughs, Success Stories. Introducing our today's topic, the mold that saved millions, the evolution of penicillin. The story of the most important medical discovery in human history begins not with a calculated breakthrough, but with a messy desk and a much-needed vacation. In September of 1928, a Scottish bacteriologist named Alexander Fleming returned to his laboratory at St. Mary's Hospital in London. He had been away for 2 weeks, leaving behind a stack of Petri dishes smeared with Staphylococcus aureus, a deadly bacterium responsible for boils, sore throats, and abscesses. As Fleming began sorting through his neglected cultures to decide which to discard, he noticed something peculiar about one specific dish. A stray mold spore, likely drifting in through an open window, had taken root. Around the perimeter of the greenish-blue mold, there was a clear, translucent ring, a zone of inhibition where the deadly yellow staph bacteria had simply dissolved. Fleming remarked with his characteristic Scottish understatement, "That's funny." He realized that the mold was secreting a substance that didn't just inhibit the bacteria, but actively destroyed it. He identified the interloper as Penicillium notatum. He began to grow the mold in pure cultures, finding that the mold juice it produced was effective against a wide range of gram-positive pathogens, including those that caused scarlet fever, pneumonia, and meningitis. This serendipitous moment was the birth of the first true antibiotic, but it was far from ready for the world. However, Fleming faced a massive wall. He was a bacteriologist, not a chemist. Every time he tried to extract the active ingredient from the mold broth, the substance broke down. It was incredibly unstable and disappeared within hours of being processed. After publishing his findings in 1929 to very little fanfare, Fleming eventually moved on to other research, and for nearly a decade, the world's first miracle drug sat as a forgotten curiosity on a dusty library shelf. It remained a laboratory novelty, considered too difficult to produce and too weak to be useful in a clinical setting. The scene shifts to the late 1930s. Europe was on the brink of a catastrophic war. In a small, underfunded lab at Oxford University, an Australian pharmacologist named Howard Florey and a brilliant German Jewish refugee named Ernst Boris Chain stumbled upon Fleming's old paper. They realized that if they could stabilize this substance, they could change history. The Oxford team was a ragtag group of geniuses working with makeshift equipment, an assembly of milk churns and cooling coils. Chain, the chemist, worked tirelessly to find a way to freeze-dry the substance into a stable brown powder. By 1940, they had enough to test it on mice. The 4 treated mice survived a lethal infection, while the untreated ones died. This was the definitive proof. Penicillin was a powerful medicine. The first human trial followed in 1941 on Albert Alexander, a policeman with a horrific systemic infection. Within 24 hours of receiving the Oxford penicillin, his fever dropped and his appetite returned. It was a miracle. But the mold was so difficult to grow that the team had to recycle the drug from the patient's urine to keep the treatment going. Eventually, the supply ran out. Albert Alexander relapsed and died, proving the drug worked, but also proving it needed to be mass-produced on an industrial scale. With Britain under bombardment, Florey flew to the United States to seek help. In Peoria, Illinois, scientists made 2 critical discoveries. First, they found that corn-steeped liquor acted like rocket fuel for the mold, increasing the yield exponentially. Second, a lab worker brought in a cantaloupe covered in a pretty golden mold. This strain, Penicillium chrysogenum, produced 200 times more penicillin than Fleming's original sample. The US government declared penicillin a top wartime priority. By D-Day in 1944, there were 2.3 million doses ready. For the first time, the leading cause of death in war, wound infection, was being defeated. When the war ended, the yellow magic became available to the general public. It transformed human life. Diseases that had decimated families for centuries, syphilis, rheumatic fever, and blood poisoning, were now cured by a simple injection. Life expectancy climbed rapidly. It allowed for modern surgery. Without penicillin, heart transplants and chemotherapy would be impossible. In 1945, Fleming, Florey, and Chain shared the Nobel Prize. In his speech, Fleming issued a warning. If the drug was used too frequently or in too small a dose, we would create superbugs. Today we live in the shadow of that prophecy. The evolution of penicillin has led to a global arms race between human ingenuity and bacterial adaptation. Strains of MRSA remind us that the age of antibiotics